Question 36. The circle in the figure above has center O and radius R. If OB is equal to OD, how many of the line segments shown with labeled endpoints have length R? So, in order to find the number of segments that have the length equal to the radius of the circle, we first just figure out what possible segments are there and find and check if they are equal to the radius. So which are actually the radius? I mean, we find the radius first. Which one are actually? I mean, we can easily explicitly see that they are actually the circle's radius. So obviously, the one that have that the segments that connect the center of the circle with one of the points that lies in the boundary of the circle, and that they will always be the radius, right? The segments that connect the center and what a point lying in like on the circle, which is, so we have A, E, and C, a point on the circle, right? So OA is always equal to OE, and always equal to OC, and this are actually our three radius, and this is obviously equal to R. So this is local case R. Um, and what else? And then after we've figured out all the actual radius, so we need to find out what else is equal to the radius besides the radius itself. I mean the radius themselves. So the radii themselves. So um, okay. So notice that BOD, triangle BOD, is a right uh, isosceles triangle. Why? Because like the question said, OB is OD, so it's an isosceles triangle, but it's a right isosceles triangle because it has a right angle here in the corner O, in the vertices O. So this is the right, it's right isosceles. So let me write that. Iso Celeste. So because it's a isosceles triangle, so angle B is always equal to angle D, and is equal to and B equal to D, but B adds up to D to a right angle. So each of B and D is equal to half of 90 degrees, right? Which is 45 degrees. So B and D is equal, and therefore equal to 45 degrees because this is a right isosceles triangle. Um, B and D is 45 degrees, and we also have the right triangle BOE and OED. They are both triangle. Actually, they are actually similar to each other. I mean, they are actually congruent to each other. BOE and DOE, because they share the same edge, and they I mean the angles are the same. So they must be congruent to each other, right? And furthermore, they are also right isosceles triangle because they have one of them corners, the angles, one, so each of them has an angle equal to 45 degrees. So they must be isosceles triangle. So BOE as well as um, BOE and OED is also a right triangle, isosceles triangle. Let me just write this down because this is a right isosceles triangle. We can easily see that BE is equal to OE, right? Because of BOE here, and OE is equal to ED as well because OED is a right isosceles triangle. And notice that OE is R, right? It's length R. It's a radius. So these three segments must also be equal to the radius, because this is equal to OE and it's the radius. So we already found how many so we already found, I mean, one there, two, three, four, and five. So OE here. So we have already found five segments which are equal to R. So what else is equal to R? Let me see. Definitely not OB and OD because they are obviously larger than R. BD, I mean, obviously larger than R. AC is also larger than R because it's the hypotenuse of the triangle OAC, and it's larger than its size, and its size of the radius of the triangle. So AC is obviously larger than R. What else? I think we have found all the segments that are equal to R. So they are so in this figure I can only find five segments that are equal to R. So I think the answer should be five, which is D for question 36.